Chronic pain affects up to 40% of young people, and this is pain that lasts longer than 3 months. It can have devastating effects on these kids, but research underway at the University of Calgary hopes to change that. Here to tell us all about it is neuroscientist Jillian Vinall. Good morning to you, Jillian. Thank you for coming in.
Thank you so much for having me.
I was really shocked when I read this statistic that up to 40% of kids are in so much pain for so long. How common is it?
Well, there's a range. It ranges from anywhere from 15 to 40% of kids. But the most common pain that occurs is chronic headaches in children.
Oh, amazing. So when they have this much pain, what does that mean for their quality of life for these kids?
It's very difficult for these children. So chronic pain is associated with significant disability, social isolation, poor quality of life, and if not managed properly during their childhood, adolescence, it can actually persist onto adulthood. And
then you've got all kinds of big problems when you've got adults, because then adults, of course, can be kind of addicted to all kinds of painkillers and things like that.
It's possible if they're self-managing and don't have a proper team managing their pain. So yeah, and then not only is chronic pain has this potential to persist, but it's also associated with a number of mental health conditions. So about 30% of all youth with chronic pain have post-traumatic stress disorder or post-traumatic stress symptoms, which is stress that persists after being exposed to a traumatic event. And similarly in adults, it also occurs in about 10 to 80%. And even if the pain resolves into adulthood, oftentimes these mental health conditions persist.
They remain. Wow. So this is really important, which brings us to your research. So tell us a little bit about what you're looking into.
So we're really interested in why this co-occurrence might happen. And so we know from the literature that as pain becomes chronic, it tends to move in the brain from being processed in these physical sensory regions of the brain to more of these emotional centers of the brain. And you've
actually seen this in the brain. We've got scans that we can bring up and show. So you've targeted 2 specific areas of the brain, is that right?
Well, we're looking at multiple regions of the brain, but I did provide you a couple of pictures to show you 2 very common regions that are involved in pain processing.
And this is one of them?
This is one of them. So this is what's called the anterior cingulate cortex, and it's very much involved in the emotional processing of pain. And then the second image is actually of the left posterior insula, and this is involved more in the physical processing of pain.
The physical processing of pain. Interesting. Okay. So it's these sort of imaging that you can do that's really helping you study this, isn't it?
Yeah, so we're really interested in where this co-occurrence might overlap in the brain. And by understanding this better, this can help us to better target both chronic pain and their comorbid mental health condition, and maybe develop even new therapies that will better treat these individuals. Because unfortunately right now, our therapies are not proving to be very effective.
Right, okay. So now tell me a little bit about the study that you're involved in specifically, where you're having people look at images. Tell us a little bit about that.
So what we're doing is recruiting 30 youth with chronic headaches or migraines, and we're bringing them to the hospital on a day that they're headache-free. And then we do about an hour of scan time, so these kids are awesome. Then while they're in the scanner, we're showing them these series of faces that express either happy, fearful, or neutral facial expressions developed.
We actually have those pictures to show. They're kind of older pictures, but they've been used in many, many studies for years and years.
So the advantage of these pictures is that we know from previous studies that people can reliably detect what emotion they're expressing.
Okay.
So we know that these are going to activate the areas of brain that we're expecting, but they might actually activate them differently in individuals with chronic pain and post-traumatic stress disorder than healthy controls.
Oh, interesting.
So that's really what we're going to look at in this particular group of kids.
So what would that tell you then, that difference between those who don't have pain and those that do?
So this would give us an idea about where in the brain these changes might be happening. So for example, if it's involving memory, we could potentially do a memory reframing therapy that would really target that area of the brain and then perhaps lead to better outcomes in these youth. So we're really trying to understand where in the brain the change is happening and what we can do to really help these kids in a better way than we currently are now.
Wow. So what's your ultimate goal then for these children?
The ultimate goal at this time is just to understand where they're at better and characterize that in detail. And then once we do that, then we can really start to perhaps develop early interventions so we can get them early on before they even develop into these conditions, help the kids that currently are suffering with chronic pain and comorbid health conditions, and develop new therapies that will be even better.
Wonderful. Jillian, thank you so much for shedding some light on this, and good luck with your research.
Thank you.
Andy, let's get a check on that forecast.